Okay, in this class we're going to look at a problem-solving question based around the work we've been doing on the equation of a line. So this is a typical kind of Leaving Cert standard question. It says find the possible equations of the line AB, and we're given some information. So let's just have a look at what information we're given. Well, B is a point on the y-axis up here. A is a point on the x-axis, so we're trying to find the possible equations for this line here. And then we've got this, origin here. And it tells me the area of the triangle ABO, well, that's ABO, is 25 units. And we're also given this point here, 4, 2. I don't know if that's super clear, but that's that point there on that line. So we want to find the possible equations of the line AB. Okay, so that's what we're trying to figure out. So we're looking for a line that passes through the point 4, 2. It's a diagonal line downwards. And, the y-intercept and the x-intercept of that line together with the origin form a triangle whose area is 25 units squared. Okay, so we're trying to find the equation of that line. So what I'm going to do is just, I'm going to just think about the equation of the line AB. Or a line can be named with a lowercase letter, just like a lowercase l, or it can be named with just 2 points that are on the line. So AB, we read that as the line AB. Sometimes you'll actually see that written as AB with a picture of a line on its kind of over it like that. But here on our curriculum in Ireland, AB means the line AB. Okay, that's how we interpret that. So if I want to think about that, and I want to think about its equation, well, I can write its equation in point-slope form. Now remember point-slope form. Let me just write the general. Point-slope form in general says that y minus y1 is equal to m multiplied by x minus x1. This is called the point-slope form of the equation of a line, where x1 comma y1 is a point on the line. Notice 4 2 is a point on our line, and m is the slope. Now we don't know the slope here because we haven't given any units, but we are given a point. So we know that AB is going to be y subtract the y coordinate 2 equals m, whatever the slope is. We don't know that slope. So the key here is finding the slope times x minus the x coordinate 4. And the question is find the equation of the line. If we know what m is, well, then that's the question done. We have the equation of the line, but we don't know what m is, so we're going to try to figure it out. Okay, what I'm going to do is I'm going to change this into what we call slope-intercept form. And I do that through a couple of steps. The first thing I'm going to do is distribute my multiplication out here. And then I'm going to add 2 on both sides. So let me write these down really specifically. So just distributing on the right hand side. In other words, expanding the brackets, we're going to have y subtract 2 is equal to m times x subtract 4 times m, whatever that is. The next thing I'm going to do to make y the subject of the formula, which it is in slope-intercept form, y is the subject of the formula. I'm going to add 2 to both sides. And what I will get is y is equal to mx subtract 4m and then plus 2. Okay. Now that is in slope-intercept form. Remember slope-intercept form. Let me just write it over here in a little kind of box. This up here is called point-slope form. And PSF I'll write there. That's the point-slope form of the equation of a line. Slope-intercept form of the equation of a line is y equals mx plus c, where m is the slope and c is the y-intercept. Now here, c is going to be negative 4m plus 2, and the slope is m. So we can see the slope here is m. Of course, we knew that already. But importantly, the y-intercept here is going to be equal to negative 4m plus 2. Or I might write that as, let me write it both ways first. Negative 4m plus 2 I prefer the look of 2 minus 4m. I just prefer the look of that. No particular reason. That's the y-intercept of this line. That means that's the point B. The point B up here is the point with an x-coordinate at 0 and a y-coordinate at 2. Subtract 4 times whatever m is. Okay, a little bit squished in there. But that's the y-intercept. In fact, let me rewrite that. So 0, 2 minus 4m. That's the point B there. That's what that point is. Okay, so I found that. Notice that's also the kind of vertical height, because there's the y-axis, here's the x-axis, that's a right triangle. So that's the kind of vertical height of this triangle, which is going to be important. The next thing I'm going to think about is the x-intercept of this kind of line AB. So this is my line AB. It has equation y equals mx minus 4m plus 2. I don't know what m is, but if I did, I could write that, you know, in slope-intercept form by just substituting m in. The next thing is to find the x-intercept. And to find the x-intercept, well, every point on the x-axis, no matter where it is, has a y-coordinate of 0. So to find the x-intercept of any kind of function, we just set the y-coordinate equal to 0. That's all we do all the time. So if I take my equation, y equals mx minus 4m plus 2, I'm going to just set that y equal to 0. So setting that y equal to 0 in my slope-intercept form, I'll just get 0 equals mx minus 4m plus 2. Now what I want to do is make x the subject of this equation. And so a little bit of manipulation here. I'm going to use the addition property of equations. I'm going to add 4m on both sides. I'm going to use the subtraction property, subtracting 2m on both sides. If equal quantities are added and subtracted on both sides of an equation, then the two sides of the equation remain equal. So what I'm getting over here is negative 2. I've written negative 2m. That should be just negative 2. Negative 2 plus 4m is equal to m times x. And now I want to make x the subject of the formula, so I'm going to divide on both sides by m, and that'll give me an expression for x. So therefore we're getting, I'm going to rewrite the top as 4m subtract 2 over m, and that's equal to x. So what does that tell me? Well, that tells me my x-intercept here at A, well, that's going to be the point 4m minus 2 over m, comma 0. Okay, so now we have lots of information here. We have the y-intercept at 2 minus 4m, the x-intercept at 4m minus 2 over m, and we have this third point here at 0, comma 0. So I have lots of options from here now. I'm going to use my old primary school definition for the area of a triangle. We're given the area of a triangle. That's going to be the key here. So from primary school, let me write this out in a separate page so I have room to show all my workings here. So from primary school, we know that the area of any triangle is equal to 1/2 times the base multiplied by the perpendicular height. Okay, and if we look at our triangle, the base is going to be the distance here from the origin all the way over here to that point A. And what's that distance? Well, the change in the x-coordinate from 0 to there is 4m minus 2 over m. So that's the base. The height is going to be whatever the y-intercept is. So base is just the x-intercept. The height is just the y-intercept. We can now substitute everything in. So we also know we're given the area of the triangle is 25 units squared. So substituting in 25, That's equal to 1/2 of the base. Well, the base is 4m subtract 2 over m times the perpendicular height, which is 2 subtract 4m. Okay, and now we're ready just to solve for m. So I'm going to just get rid of my picture for a moment because it's really an algebra problem now is solving. So a couple of things I don't like. If I double both sides, that will eliminate the half. And if I multiply on both sides by m, that will eliminate that kind of division by m. So actually what I'm going to do on both sides of this equation is I'm going to multiply by 2m. So I'm multiplying by 2m on both sides. If both sides are multiplied by the same quantity, then the two sides will remain equal. On the left hand side, I'm going to get 50m. On the right hand side, well, the half will cancel the 2, and that division by m will cancel that out. So we're going to have 4m subtract 2 times 2 subtract 4m. Okay, and we're going to just multiply all this stuff out. 50m on the left hand side. And what I'm going to have ultimately here is a quadratic equation. I'm just multiplying this out in the usual way. 4m, first of all, has to multiply by every term in here. That's going to be 8m. Subtract 4m by 4m, well, that's 16m squared. And then multiplying -2 by 2, that's -4. And -2 by -4m, well, that's plus 8m. And it's an old quadratic equation. We hopefully have done these at this stage till we're blue in the face. I'll go through the whole lot from here on in, but you should be able to really solve this at this stage. Couple of things I'm going to do. I don't really like having the square term negative, so I'm going to eliminate everything from the left hand side. So I'm going to be adding a 16m squared on both sides. I'm going to be adding 4 on both sides. And I'm going to be subtracting that 8m and subtracting that 8m. So ultimately what I want to get is 0 on one side of my quadratic equation. Adding 16m squared on both sides gives me a positive 16m squared on the left. Subtracting 8m and then subtracting another 8m, so subtracting altogether 16m's from both sides on the left, well, that will leave me with 34m's. On the right, that'll cancel all my m's out. And then adding 4 on both sides, on the right, that'll cancel out the 4. On the left, that'll just leave me with a 4. So we have 16m squared plus 34m plus 4 is equal to 0, and we want to solve this. I could solve it here, but one thing I'm noting that every term on the left and every term on the right is divisible by 2, so I can divide both sides of that equation by 2, giving me 8m squared plus 17m plus 2 equals 0. Solving a quadratic equation. Remember, the product of the outer terms has to be equal to the product of the inner terms. We know the product of the outer terms is 8m squared times 2, which is 16m squared. So the product of the inner terms has to be also 16m squared, but they have to combine to give me 17m. And the only way that can happen is if we have 8m squared plus 16m plus 1m plus 2 equals 0. We've now got 4 terms where the product of the outer terms is equal to the product of the inner terms. 16m squared, product of the outers. 16m squared is the product of the inners. There are 4 times. We can factor this using grouping. So factoring using grouping. So I'm going to factor out an 8m from my first group here, and its factor pair will be m plus 2. The next thing I'm going to do is factor out, it has to be the same thing, I'm going to factor out that m plus 2 from the second group, and its factor pair has to be plus 1, 1 times m plus 2 is m plus 2. Always double check your factoring after you've done it. And that's equal to 0. We now have two terms. We're going to look for the common factor in those two terms, and hopefully it's fairly clear that the common factor in those two terms is m plus 2. I'm going to factor that out. And that's going to be equal to 0. Okay, now I'm just solving for m. I'm going to use the zero product property. Remember, the zero product property says if two quantities have a product of 0, then one of them has to equal to 0. And so solving for each of these things, solving m plus 2 equals 0 gives me m equals negative 2. Solving 8m plus 1 equals 0, subtract 1, then divide by 8, m equals negative 1/8. Okay, so we found our two possible values for m. Again, double check we've answered the question. Have we answered the question? It doesn't say find the slope, it says find the equations. We know the equations in slope-intercept form look like this. So I'm going to solve those equations by just substituting in our possible values for m in there. Okay? So we know that AB has the equation y equals mx minus 4m plus 2. We know that. So I'm just going to substitute in my two possible values for m. So if m equals negative 2, then y will be equal to mx, that's negative 2 times x, minus 4 times m. That's negative 4 times negative 2. Let me write it out specifically, negative 4 times negative 2, and then plus this 2 at the end. And then simplifying that, y would be equal to negative 2x plus 8 plus 2, that's plus 10. Okay, so there is one possible value for AB. Okay, so there's one possible value for the line passing through the points A and B. Y equals negative 2x plus 10. Now we look for the second possible solution. If m is equal to negative 1/8, then y is going to equal to, again it's mx, so negative 1/8 of x minus 4 times m, well that's minus 4 times negative 1/8 plus 2. Simplifying that, we get y equals negative 1/8 times x. Negative 4 times negative 1/8, well that's positive 1/2. Positive 1/2 plus 2, well that's plus 2.5, or I might write that as plus 5/2. Okay, so there's my possible values for AB. Okay, so AB could be either of those equations. Y equals negative 2x plus 10, or y equals negative 1/8x plus 5/2. It says find possible equations for AB. You know, if I had to guess, if this is to scale, if the x and y axis have the equal scales on them, which they don't necessarily, well then the slope of negative 1/8 looks like a much more likely candidate than a slope of negative 2, which would be much steeper. But it says find the possible equations of the line AB. There they are. Y equals negative 2x plus 10, or y equals negative 1/8 times x plus 5/2. If you want to write those in standard form, you could. They are both in slope-intercept form. If I wanted to write those in standard form, well, for the first equation, I'm just going to add 2x and subtract 10 from both sides. So we'd get 2x minus y minus 10 equals 0. That could be AB. Or AB, the line AB. This one I'd have to multiply everything by 8 to get rid of the fractions here, and then add x on both sides, so I'd get x multiplying y by 8 would give me plus 8y. Multiplying 5 over 2 by 8, well, that would give me 20, and then subtracting that on both sides, be minus 20 equals 0. So I could write it in standard form, but slope-intercept form is probably better, or just as good, I should say. So standard form, two possible values for a, b. There they are. Or you could leave them in slope-intercept form. Perfectly fine. Okay.